Dimensions Lunch and Learn. My name is Derek Welker, and today we're going to be discussing SolidWorks CAM. So this is more of a first look into the software. So as 2018 rolls out and you guys start using it, you'll notice that you have SolidWorks CAM as a functionality. So we're going to go through, talk about the different packages that SolidWorks CAM offers, what it does, and kind of the functionality that it brings to your seat of SolidWorks. So first, let's start off with an agenda here. So we're going to discuss kind of what is SolidWorks CAM, where did it come from, what capabilities does it have. We'll get into the packages. You know, we have two different packages being standard and premium. We'll discuss what those entail. I'll do a kind of a demo of CAM Standard, and then we'll do a little bit of a demo of the professional features. All right. So what is SolidWorks CAM? SolidWorks CAM is powered by CAMWorks. So for those of you who are customers of CADimensions, you know that we've been selling CAMWorks for, I think, right around 10 or definitely more than 10 years. So definitely powered by CAMWorks. You know, we are very, very familiar with this product and how it functions. So it's really a nice transition from CAMWorks over to SolidWorks CAM. So CADimensions, we're very familiar with it, and we're happy to see that SolidWorks is now integrating it. So CAMWorks or SolidWorks CAM is a feature-based or a rules-based machining package. So it generates machining operations directly from native or imported geometry. What it does is it looks at the features that we have in our model. So with SolidWorks, we're very comfortable with the term features. We know what that means, you know. But in the SolidWorks CAM world, those features mean something else. You know, we're familiar with like extrudes and fillets and cuts and revolves. Features in CAMWorks or SolidWorks CAM is like pockets, bosses, holes, those types of things. So what the automatic feature recognition does is it analyzes your geometry, determines what are holes, what are bosses, what are pockets, you know, facing operations, perimeter features, and it automatically builds those for you and then creates the toolpath for you as well. You can obviously adjust that however you see fit, but the great thing is you don't have to go through and manually define every single feature in this model for you to go ahead and create toolpaths. It kind of automatically does it manually. Now, another thing that's huge with SolidWorks CAM is we have what we call the technology database. So the database is kind of this giant list of machining methodologies or strategies. So like if you come into, or if you're looking at machining, just say a square pocket, right? In this database, there is rules that define, okay, a pocket from this size to this size would use this size cutter with all of these different parameters. But if you have something bigger than that, it would obviously use a bigger tool. So in this database, it kind of picks things that are, I guess, intelligent for the type of feature that you're working on. The great thing is you can also save back to the database. So if it picked up a specific tool that you don't want to use, you can certainly select on a different tool and save that back to the database so that when you run into a pocket or a hole or something like that of similar size, it will grab all of those custom tools and methodologies and strategies that you defined as being the ones that you want. So the more you use it and the more you save back to the database, the smarter it then therefore becomes. Another thing with SolidWorks CAM is its associativity to the model. So once you make a change to the SolidWorks model, it automatically updates SolidWorks CAM. So SolidWorks CAM does run right inside of SolidWorks. There is, you know, it's not a separate product like, you know, like Visualize or Compose or anything like that. It's just an add-in. It runs right inside. So literally while you're working, you can just make dimensional changes and it updates all your toolpaths. I will show this in just a minute. The great thing is with SolidWorks CAM, being that it is definitely significantly easier to use than some other CAM packages, just because it has a lot of this intelligence built in. It's very, very easy to learn and it's very intuitive. The great thing is it's also included inside of SolidWorks. You know, it's bundled in the UI, so that just inherently makes it really, really easy to learn. So the two packages that we have are SolidWorks CAM Standard and SolidWorks CAM Professional. So CAM Standard is included with every seat of SolidWorks but the only caveat is you must be on maintenance. So if you are on maintenance with 2018, you do have SolidWorks CAM Standard. If you are off maintenance, then you have to either get on maintenance or purchase SolidWorks CAM Professional, and that will get you that license. The other thing with CAM Standard, it does not require a serial number. So when you upgrade to 2018, you don't have to come to us and ask us for a serial number for it. You literally just install like you normally would, make sure that SolidWorks CAM is listed in what you're going to be installing, and it will be right there for you. Now, SolidWorks CAM Professional does not require you to be on maintenance. So if you're off maintenance or you need some of the professional functions, you can certainly just purchase that. So it is a secondary, it's a separate purchase, but it does not matter if you're on or off maintenance. It does include the standard and pro capabilities. So if you're off maintenance and don't want to get back on and buy professional, you can just buy professional and you'll get standard and pro. There's also some additional capabilities of pro, which we'll discuss in just a little bit. So let's get into SolidWorks CAM Standard. So it's included with every seat. We already talked about this. It includes 2.5 axis, tolerance-based machining. So if you are using MBD, it'll analyze the tolerances that you've applied to specific faces, and it will define rules and strategies to maintain that tolerance type. It also has the functionality to machine to mean, which is very, very potent and powerful. But this is obviously, it's only used for if you are applying those DIM expert dimensions and annotations and GD&T specifically to your model. It also includes what we call advanced 2.5 axis. In some cases, you might hear that SolidWorks CAM has 3-axis capabilities. It's kind of 3-axis, but not really. We'll talk about that a little bit more in depth in a little bit. For now, we'll just call that advanced 2.5 axis. And then they also included high-speed machining. So what is high-speed machining? So high-speed machining in the software is called VoluMill. So VoluMill was, if we go back to 2017, if you bought CamWorks and you wanted high-speed machining, you actually had to purchase VoluMill as a separate add-in. Now it's being included. So what it does is it reduces your programming time. It cuts faster and deeper with less tool stress. Basically what it does, it creates an even distribution of wear on the tool by doing radius cuts. So what you'll notice in some of these tool paths up here is it's just doing these long radius tool paths. Now in this case, it's going back and forth. You can have it just maintain a specific climb or conventional cut, and it really does extend the tool life. We've talked to a lot of people that have been running VoluMill in the past or are running this high-speed machining on other on other softwares, and everyone loves this capability. It's extending the tool life significantly, and it's also significantly quicker when actually cutting. All right, so that is included with SolidWorks CAM Standard, which used to be a separate add-in to CamWorks. So a nice thing that they kind of bundled in. So what are we going to do during the demo? So I'm going to talk to you about how SolidWorks CAM automatically defines those features, that automatic feature recognition like what we just talked about. I'm also going to show you how we go in and manually define features if it doesn't grab everything. We'll talk about how we sort and modify our tool paths, maybe adjust the size of things, maybe change the pocket size, strategies. We'll save the operations back to the database. I'll kind of explain that a little bit more in depth. We'll talk about VoluMill and that high-speed machining. I'll go in and I'll make a revision change so that you can see what happens when you change a dimension. And then we'll get into 2.5 advanced machining. All right. So this is actually one of the what's new data sets. So if you came to our 2018 what's new or seen a lot of these demos, this is actually kind of an emergency brake of some sort. Actually, no, sorry, this is a hood hinge for the Ring Brothers De Tomaso Pantera. I know it's a mouthful, but it is a beautiful car here. So let me just open up this model, and we're going to get in and start working. So first, let's identify what SolidWorks CAM is. Right here in our feature tree, we actually have 3 different tabs. We have the CamWorks feature tree, the CamWorks operation tree, and the CamWorks tool tree. Up at the very top in our command manager, we do have a tab specifically for SolidWorks CAM. So starting off, this is where we define our machine. We'll then go in and define our stock. So the reason why we define our stock is when we go and simulate this, we'll actually see what's going to be cut. Also, we can identify which material we're going to be using. So in this case, I might use 6061. The reason why we identify material is because SolidWorks CAM has a feeds and speeds library that is based on the material that you're using. So dependent on material, it will automatically adjust the feeds and speeds for you. Obviously, you can overwrite that if need be, but it is a nice feature that's included. Also, if you typically true up your stock to size, you can add some additional material to your XYZ offsets so that it goes along with what you would actually be cutting out on the machine. Right? Now I'm going to specify my coordinate system. Now in this case, I'm just going to say I just want to go off of the corner of one of my stocks, or of my stock, and we'll just accept that. So I'm just going to go ahead and say extract machinable features. This is that automatic feature recognition that we were just talking about. You can see it says extracting whole features, extracting these manufacturing view features. So it's going through analyzing our geometry to give us our pockets, our holes, our bosses, our perimeters, our facing features, and everything like that. All right, so you can see it actually gave us all of our features, our facing, our perimeters, our slots. I'm just going to suppress this one really quick for an example. And then we'll go over into our operation tree, and you can see that we have all of these operations. Now, all of these are kind of like a dark blue. I know it might be a little bit hard to see, but they are dark blue and not black. Now, when I generate my tool paths for those, they'll actually turn black, or the ones that can actually generate tool paths turn black. So these ones that are blue, they can't actually define the tool path for them. So this is where we'd either need to go in and change a tool size, change something in there to allow it to be accepted. So this kind of helps us define or show if there's an issue with that specific tool that it's trying to use, right? So we can go in, we can modify this. In this case, this tool might be a little bit big for what we're trying to do. So we can go in, make any adjustments that we need, hit OK, and kind of work through it. But I've quickly gone through and just applied tool paths to basically this entire model. So let me just simulate this real quick. So I'm just going to go through, do a real quick simulation, and you can see it goes through and works through a quick simulation. So just in a couple of minutes, I mean seconds really, we were able to kind of get almost a fully machined part. Now, one great thing is I can actually show the difference. So I can see what material I have left. So in this case, I did suppress one of those features, which was this cut here, just so I could show you what would happen if you had to manually add this in. Right, so let's go back over into our CAMWorks feature tree, and let's just add in that feature. So I'm just going to say create a new 2.5 axis feature. I do want it to be an open pocket because it is open. So when we specify an open pocket, it means that we can have like a lead in and lead out that's outside of our stock. So instead of plunging into the stock, we can have it kind of start out and move in. I'm just going to select on that face, and in our end condition, this is where I typically select like the topmost face of my part. But in this case, in my end condition, I actually want to say up to stock, so that regardless of if we add on more stock to this or change the size, it's always going to extrude or machine up to the top of the stock. Right? These are some of the smarts that we build into SolidWorks, right? Because when we're doing a traditional cut, we say cut through all. This is a very similar idea. So let me generate my operation plan here. I'll go down and I will generate my tool path here. And as we go through and simulate this, once it gets towards the end, you'll see that it goes through and cuts that out. Now, another couple things that I wanted to kind of take note of here while we're talking about this. So as this goes through and just finishes up cutting, we'll give it 1 second here. Right, so as we compare it, everything looks good. What I do want to point out is we actually have the ability to define collisions between like our shanks, our holders, and our tool, whether it's rapiding. So let's go to the beginning, and we'll see if we actually have any collisions between the tool shank and our part. right? So in this case, we're saying we have an issue between the tool shank and the stock. So if you put in your correct tools, you'll know without having to just know while you're doing this, it will automatically determine if you're going to have issues with shanks, holders, and tools during your rapid moves. So there is a lot of smarts that are built inside of the software that are going to help you through. Right. So now let's go over to my rough mill here, and let me just change some of these settings here. So we did talk about high-speed machining. So I'm going to go in and I'm going to change this to being my VoluMill. Go ahead and click OK here. And this is our high-speed machining. So what you'll notice is we get these nice radial curvature cuts. And if I go in to just simulate this guy here, let me bump down the speed. What you'll notice, whoops, forgot to hit play, right? You'll notice that it does these swooping curvature, equally radiusing cuts. It doesn't take any harsh movements into the material. It kind of maintains that load on that tool all the way around. So it's very, very efficient in cutting because it does not, generate or apply a lot of stress to the model. So there are some parameters that you can adjust in this if it's not absolutely perfect, but for the most part, just default, it does a pretty decent job at going through and creating everything that's need be in here. Right. So if in this case I always wanted to do my perimeter by using a VoluMill, I can actually go in and let me save this back. Now I have to go back over here and say that my perimeter, save this operation back. So what this does is it's saying, okay, in a parameter or a perimeter type feature, if you run into something very similar, I want you to save all of my settings here, my tool selection, my VoluMill settings. If I change it to be like a climb or conventional, it'll automatically pick up on that. So I'm saving it back to the database so that next time I run into this, like doing an automatic feature recognition, it will pick up on all of the methodologies and strategies that I'm looking for. Right? So it's super, super helpful. I'm actually going to cancel out of that. And before we move into talking about advanced 2.5 axis features, let's just do a quick dimensional change, right? So one thing I just forgot to mention here is that when we do that save operation plan back, it just helps us later on down the road. So when we run into something similar, we don't have to go through and make all of those adjustments over and over and over again. It does get smarter the more you use it. Okay. So I'm going to go in and I'm going to make this small little dimensional change from 28 to 24 because we know that revisions never occur in the real world here. So when we hop back over into CamWorks, or SolidWorks CAM, sorry, it automatically pops up and tells us that, there have been dimensional changes and we need to adjust or address those. So in this case, once we hit OK, it goes through and analyzes all of our tool paths and makes the appropriate adjustments here. Right, so just taking a look at some of those pockets in here, you can see just looking, all of these pockets are adjusted based on that size. Let's just simulate this real quick. We'll go through this super fast. I'll throw on turbo mode, which will kind of get it done real quick. And we can do a nice little compare and everything's good to go. So that's one huge benefit of SolidWorks CAM is the fact that once you make a dimensional change, whether it be a pocket size or anything whatsoever, and you hop back over into SolidWorks CAM, it immediately sees that and you can go ahead and allow it to make those updates. Right? Some of these other CAM packages, you have to re-import the new revision or something like that. In this case, you never have to do that. Another thing while we're talking about revisions is that SolidWorks CAM saves all of the data right within inside of the SolidWorks model. So, it's not like the engineers will send the machinist a SolidWorks file and then, there's a new revision and they have to re-import it or they have to save their own files. It literally just saves within inside of the SolidWorks model. So as long as that next revision comes from the previous revision, which in all cases do, all of that data will still be in there. Right. So let's hop over and let's talk about some advanced 2.5 axis machining capabilities. So I have this funnel here, or this is what this part's called, and it does have some 3-axis cuts in here, or what we would deem to be 3-axis, right? We've got this nice solid curvature down. So what I'm going to go ahead and do is I'm going to just quickly throw on a quick setup, and we're going to apply what we call a multi-surface feature. So this would be our 3, 4, 5-axis stuff. In this case, we're just going to do an area clearance and a Z level. So we really only have a Z level as our option in this case. So I'm going to generate our operation plan, generate our toolpath. So this advanced 2.5-axis functionality that we have is just Z level cuts. So it may be referred to as 3-axis. It's not really 3-axis because a Z level cut literally just goes in one Z level and then it steps down to the next level and cuts. So it's not doing full 3-axis at once, but it does allow you to do, I guess, 3-axis contours by only utilizing 2.5-axis. In this case, let me just do a quick little contain area here so it will maintain in that specific area. So just some nice tools and functions of SolidWorks CAM is the fact that you can do like a void and contain areas. So you can see that it does do this 3-axis cut fairly nice for only being 2.5-axis. And if we simulate this, or it's not going to be a whole lot to see. Whoops, I left it in turbo mode. I'm sorry. Right, so you can see it does one Z level, steps down. And then it does one Z level, steps down. All right, so you can do 3-axis contours or geometry with this, but it really only does a 2.5-axis cut. So let me show you another part. So on this funnel, it actually would work pretty good as long as you get the step over looking okay. Now, if I open up this other part as part of our hood hinge, I want to machine out this shape right here. So let me show you what that would look like. So when we were talking about doing this Z level, right, we know that it only does one Z level cut and then it moves down to the next depth. Right, so I'm just going to go ahead and rebuild this and generate an operation plan, and I'm just going to generate our Z level. Right. So what you'll notice is that it only does these back and forth cuts because it can't actually do 3 axes at the same time. So it can't come down and follow along this contour here. It actually has to go back and forth because it's not doing the full 3 axes at the same time. It's only doing your X and your Y. So it can't actually come down and go back over. So it is limited in this case, and our step over is defined not by a horizontal step over, it's actually defined by a vertical step over. So we're saying that our depths are going to be 0.01. So it's looking at the depth or depth change to determine where those Z levels are going to be. So in this case, you can see where where the slope of this is a little bit smaller. The distances are bigger than when it's a little bit bigger of a slope. And then when you get to the bottom, when it's virtually nothing, there's no steps because there's no change in depth, right? So that is another limitation to this kind of advanced 2.5 axis. So on that funnel part, yeah, if you're doing like a pocket, it actually works pretty good. But in this case, for this geometry, not so much, right? So this is really a limitation to this advanced 2.5 axis is what they're calling it. So if you're looking to do these kind of swoopy stuff, some of it might do okay. Some of it you might have to look into CamWorks, which offers a full 3-axis package. Right, so I did want to discuss the limitations to the software as well. So you didn't go into it thinking that you had full 3-axis capabilities or could do these 3-axis stuff. You know, yes, you can, but there are some limitations like I just showed. Right. So we talked about automatic and interactive features. So we ran through that automatic feature recognition, but I also did it manually, right? I just quickly selected on a couple faces and that's what generated it. I didn't need to create sketches or create more geometry to do so. I just used the faces that were inside of SolidWorks. Sorting and modifying toolpaths, I did talk about how we would go in and adjust some toolpaths like that by changing size and changing parameters. Now, sorting the actual toolpaths, CAMWorks or SolidWorks CAM has a sorting operations where you can quickly sort by different parameters. Like you can do all of your roughings before your finishes, all your center drills for everything before your drills, and you can also kind of combine operations together that utilize the same tool so that you're not frequently changing the tool. So there are a lot of these things built in that are very, very quick. Saving the operations, I showed you how to save back to that database, right? I didn't show you how that would return work if you were to automatically run that through feature recognition again, but you know, you guys do have the software, so you can definitely take a look at that, right? VoluMill, that's our high-speed machining. I showed you how that worked and kind of what benefits that give you. It is kind of the new craze in the CAM world right now. So it is super big, it's included, and it's really, really awesome. Talking about revision change, you know, going in and just making that quick dimensional change that is needed, that then therefore subsequently updates your CAM data. This is huge. You know, you don't have to re-import your models. You don't have to recreate all of those toolpaths because there is a revision change. You literally just go in and update your toolpaths, and then obviously if there's more features that you didn't account for beforehand, you just add in those features. And then we did discuss 2.5 axis advanced machining. We discussed those limitations and what it can and cannot do. And I hope that gives you a very good impression to the software and what SolidWorks CAM has to offer in the standard package, right? There is a lot of capabilities for it. You know, if you're just doing 2.5 axis parts, it's awesome that it comes free. You know, you get that high-speed machining and you get a lot of intelligence built into the software with the technology database, the feeds and speeds and everything like that. So moving on to SolidWorks CAM Professional, the professional package, right, we already discussed is an additional purchase. So you would need to purchase this separately, and but it does include assembly machining, turning, and 3+2 machining. So the 3+2 is not really something I show. What it does is the 3+2, it just takes the setups that you create, and when it posts it out, it just allows the post to adjust for, or allow your machine to adjust, you know, your different axes. Like if you just have like a rotary table, it will allow it to spin or move the part or something like that. So I can't physically show you 3+2, but you kind of get the gist. So let's start off by discussing assembly machining. So let me just open up that assembly that I want to work on here. And while we're working inside of an assembly, we then specify the parts that we actually want to machine. So we go into our part manager and I manage my parts and I say, okay, I want these two instances, these both arms. Those are the instances that I want to use. In my stock, I can actually have these individually, or I can group them together. In this case, they're automatically being grouped, right? I can actually have them, we'll start off by having them each individual, but then I can select on both of them and say group them together, and it will create one common stock for both. So if you have like 5 or 6 parts that you cut out of one blank sheet of aluminum or steel or whatever, you can automatically have it create that stock for you, and then you use that to cut out all your parts, make it more realistic. So in our setup here, let me just clear this out real quick. All right, we're just going to run extract machinable features like we would if we were just doing this in a part level, right? So we'll go in, we'll extract our machinable features, we'll generate operation plan for them, and then we'll go through and simulate this. Right, so as we go through and simulate, what you'll notice is those clamps that I had in there, I just threw in a couple clamps. You know, those don't really have any effect here, right? So let's go in and let's add in those clamps as part of our setup so that CAMWorks or SolidWorks CAM will automatically adjust around these. And I know I keep saying CAMWorks, but I've been saying CAMWorks for the past 5 years, so to call it SolidWorks CAM is just a kind of a rack in my brain here. But we go into setup and we'll then specify our fixtures. So in this case, I can just select on this clamp. I can add all instances of that clamp, and I can avoid all of those. Now, what that does is it analyzes what tool paths would actually collide with that clamp and will automatically avoid it. Instead of going through and you determining what tool paths run into what and creating a sketch to create avoid areas, this will automatically do it for us. So now I'm just going to go ahead and simulate. You can see that now the clamps show up in our simulation. And as I go through and run the simulation, it does not cut into the part or cut into those clamps. So you can see, if you are clamping your machine or anything like that, you can actually put in those fixtures and simulate it for real. So you can have SolidWorks CAM automatically avoid those specific clamps and then, make different setups for those. So you can get it super, super realistic by using the assembly machining. Now, the next thing I want to talk about, last but not least, we're going to discuss turning. So turning is probably one of the easiest things in SolidWorks CAM to do because it does look at it specifically in just a 2D environment. So we have to specify that we are using a turn machine, so a single or dual turret. Single. We just do our extract machinable feature. So in the turning operations, it just basically does a section view of this part, creates kind of a 2D representation of it, and just cuts those out. So let's go through and simulate these. Right, so you can see in my couple setups here that we do have some issues where it's not cutting out everything. So we take a look at some of these grooves. If we just view what's going on here, you can see that our tool is obviously not going to cut into these grooves because it's going to hit. So if we go into our holder, we'll just do a left down, and that will give us what we're looking for. We hit OK. And we're just going to generate that toolpath. You can see that it now generates. So for the other three, I'm going to have to do those. And we can just simulate this, and it now simulates. Right. So, you can see how easy it is to adjust these tools. You can see it does break it down into kind of this 2D layout like I was just talking about or just discussing. And one thing I haven't showed, but, once we get all of these toolpaths where we want them, we literally just post this guy out. I can save it right to my desktop. Right, let me just play through this, plays through all of our G code. And then if we need to go ahead and open it, let me just open it up real quick here. On my desktop, we actually have a setup file and our text document. So we have our G code automatically out, and then our setup file we can open up in Notepad, and it will give us all of the tools that are being used, where they are in the crib, what station they're at, and everything like that. So let me hop back over into my presentation here. So, we did discuss that assembly machining, how you can incorporate these fixtures into your SolidWorks or into SolidWorks CAM so that you can visually see what's going to hit, and making sure that you're not cutting into your machine or cutting into your fixtures. The turning module is very, very easy and simple to use. And I mean, if you need any sort of turning, you got to go to the professional package. That 3+2 machining is just kind of going off of what we already discussed, except there are multiple setups. Just so it's pretty much the same. So, as far as SolidWorks CAM goes, it is a lot of functionality that's built right into SolidWorks. It's huge to be built in, because CamWorks itself was right around like $5,000. Actually, what you get being the 2.5 axis with VoluMill, you're looking at somewhere between $6,000 and $7,000 that used to be a separate purchase, which is now included. So, I mean, that's a ton of functionality and a ton of capabilities that are built right in. The Professional, if you do want the assembly machining or if you need the turning, it is a separate module. But for the most part, the CAM Standard is really going to be what most people are going to use, and it's going to be a huge benefit. Now, also remember that if you do need 4, 5-axis, or even 3-axis capabilities, or mill turn with live tooling, we do also support CamWorks, which has or which supports those functions and capabilities. But this is just a new tool. I wanted to show it to you guys as what you now have, some limitations to it, and just kind of the software in a whole as an overview or a first look. So I really appreciate you guys sticking in with me for this Lunch and Learn. If you have any questions, feel free to ask them at this point. If not, I thank you for joining. Hope to see you in the next Lunch and Learn. Have a great day.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.